Okay, let's install that 20 convolution expansion joint into our model. What we're going to do is open up layout one more time. Remember, we saved out demand off of that model the first time. This time we're going to open up layout and immediately save it as modeler. So in Caesar 2, go to the main menu and open layout. Again, there's demand. We don't want demand, we want layout. Open that. Go into the input processor and immediately say File, Save as Modeler. We wish to use the Caesar 2 modeler. Save that. There it is, modeler. What we wish to do is come in here and install the expansion joint between the pump flange and this flange. I'm going to cheat a little bit. I'm going to leave this flange alone and install the expansion joint on this run of pipe. Now, we already have a system here. We're going to cut our expansion joint into an existing system. The same process we use here would be entering a new element as well. So you don't have to build it first, then cut into it. So let's click on this element, second element, 20 to 30, and here is that element. Now, if I wish to install an expansion joint in this element, I click on the expansion joint checkbox, and that will then allow me to find the stiffnesses. That's not what I'm doing here. Instead, we're going to have the program collect the data from the catalog and install the expansion joint automatically. So on the element 20 to 30, we wish to use the expansion joint modeler button, which is right underneath your valve flange database. There it is, expansion joint modeler. Click on that, and it's going to install that joint on this element 20 to 30. Click on the expansion joint modeler. And yes, we were using the Senior Flexonics Pathway catalog. We'll use this joint. We have several other manufacturers' catalogs included with Caesar 2. We're using the default catalog. A lot of this work of this modeler was done with the assistance of Senior Flexonics Pathway. So here's our modeler for Senior Flexonics Pathway. First, set your pressure to 50 pounds. Different styles of joints. We're putting in a tied expansion joint. Convolution material, I'll stick with 3 or 4 stainless. This is more function of what type of service you're in and what temperatures and the like. Number of convolutions, we go to 20. As far as end types, this is the connections that are shipped along with the expansion joint bellows directly. And for this pipe size, 8-inch pipe, we'll say we have slip-on flanges on either end. On the bottom row, it's a temperature adjustment. There's no only one temperature here. This is the rating temperature for the expansion joint. The catalog lists the stiffnesses for this temperature. Now our temperature is a little less, 600 degrees Fahrenheit. This is 800 degrees Fahrenheit. Liner and cover, this is just added dead weight. We're not going to do anything here, so I have it all set up and just say OK. Now this joint is not 3 feet long. The assembly is not 3 feet long. So since we have a longer length here than the joint, it's asking, do we want to button it up to node 20 or button it up to node 30? Well, I want to put it at the front end, so just say OK. One more question here. The program says, hold it, your line is at 600 degrees Fahrenheit. The catalog values are set for 800. Do you wish to adjust the joint stiffness and temperature? I'll say yes, for no other reason than to show you what this difference can be. Click yes. And here is my screen showing me my data. The program will go 20 to 21. This is that slip-on flange. 21 to 22 is the expansion joint itself. 22 to 23 is the other slip-on flange. I'll skip the last one, 23 to 30. That's the remaining straight pipe. There's this extra element here, 20 to 24. This is the tie rod model, sharing the same starting node, but a different ending node. And then a node C-node pair between 23 and 24 will attach the tie rod to the other side of the joint. The program lists our stiffnesses. These are right from the catalog, 393, 336, 76, and there's a torsion value. This is as tested. Since I said yes to adjusting temperature, they'll get a little stiffer. One other item here, the program is showing us the allowed movements of this expansion joint. I'm going to write down these numbers real quick. It's axially 3.46, laterally 1.53, 10 degrees rotation, and 0.212 degrees rotation. I write these numbers down here because later we will be looking at the demand on the joint and see if we are exceeding the total travel of the joint. So click Build. The joint has been installed. And if I look at my model, there's my expansion joint. I'll look right down the axis here. This is the original flange. Here's my slip-on flange. Here's my expansion joint. There's the other slip-on flange. These arrows are indicating the tie rod connection. Where is the tie rod? Well, it's right up to the middle of the unit. I made translucent so I can see inside the elements. Now I'll turn off the restraints. And there's that tie rod model. If I look at the tie rod model, here's the tie rod 20 to 24, 16 inches long, restraints. There's 24 to 23 in the Y, RX, RZ. So this is the tie rod connection. Also on the tie rod, note that the machine will set this element to 70 degrees Fahrenheit. The tie rods will not get as hot as the piping system at 600 degrees Fahrenheit. So that might be important. Also, the tie rod is called a rigid element. So we have our expansion joint in the model. We can go ahead and run the analysis. Click the running man. There's a job called modeler. Now, the purpose of the expansion joint was to reduce the loads on the equipment. So we'll go back to that same operating load case, nozzle check. So that's what we were looking at originally without the expansion joint. Let's look at it now. We're half the allowables in load, and we are over the allowables in bending, but we're less than 2 times the allowable. And there are some clauses in API 610 Annex F that will allow us to exceed the table values as long as we're less than 2 times. So this expansion joint may do the job. We'll have to do more detailed examination of the pump itself, provided other parties agree to this. So our expansion joint does seem to work. We've now covered most of the types of expansion joints you have in Seizure 2, as far as the zero length, the finite length, the expansion joint modeler. The other concept that we wish to talk about is a more complex expansion joint, and we'll start our next session with that concept.